Physical Sciences, grade 11 and 12. I welcome you to today's lesson. We are going to look at Newton's second law. We know that this law says that when a net force is applied to an object of mass, it accelerates in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass. You can see that I've put the mathematical expression of this law, which is the F net equals to ma, the mass and the acceleration. So let's look at the problem that we're supposed to solve or to answer. It says that a 5 kg box is connected to an 8 kg box by a light piece of string, 5 kg, 8 kg, the string. A 24 Newton force acting at an angle of 25 degrees to the horizontal pulls the 5 kg box to the right as shown. We know that the motion is to the direction of 5 kg and 8 kg is to the right. If the frictional force acting on the 8 kg, frictional force, a force between the 8 kg box and the surface, we are told that is 3 Newton. And the force, frictional force between 5 kg and the surface here, we are told that is 2 Newton. And we are required to calculate the tension in the string. So how do we solve this problem? We will work with 8 kg first, then with 5 kg, or 5 kg first. After that, we go to 8 kg. We are going to use this mathematical expression to solve this problem. Let's say we have chosen to start with 8 kg block or box. For 8 kg, what one must do is to draw a free body diagram of 8 kg box, and one must only indicate the horizontal forces that are acting on the 8 kg box. This is what I've done here. I know that there is F normal and FG, but they are not going to be useful here because the motion here is horizontal. It's not vertical, it's horizontal, which means that I must only consider the horizontal forces. In this case, is frictional force and tension. The second thing that one must do is to choose the direction. I've done it here. I've said to the right is positive. A force which is pointing to the right is positive, and the one which is pointing to the left will be negative. After choosing the direction, I then write my F net equals to MA. F net equals to MA. The F net here, we know that is the sum of the forces. Which forces? The horizontal forces. In this case, is tension and frictional force. F net equals to MA. What makes up this F net? I've already said it, that this F net is made up of horizontal forces, which is tension and frictional force. But the tension will be positive because it is pointing to the right. And then the frictional force will be negative because it's pointing to the left. Equals to MA. Next step, if I have values, then I will substitute. Tension, I don't have it. That's what I'm looking for. Frictional force is given. is minus 3 or is 3, it will carry negative as FF is negative. Mass is 8 kg. A, or acceleration, not given. Then I'll make this T subject of the formula because that's what I'm looking for. It means that I'll take the minus 3 to the other side and it will become positive. If you check here, I have A and T. So I cannot get T if A is unknown. I cannot get T if A is unknown, if I do not know A. So I will say this is an equation 1. I cannot move on because I don't know A. Then I'll move to the next box. I'll move to the next box for 5 kg, and then I'll do the same. I'll draw a free body diagram of the horizontal forces. Is tension, is FF. Remember, here I put FA. I'm not going to use this FA, but I've put it here so that I will be able to explain why am I putting this other force here, or FAX. Remember, this FA is not parallel to the surface, but there is a component that I can get using this FA, which is parallel to the surface. In this case, that component is FAX. FAX is one of the horizontal forces that must be taken into consideration in this case. And we know the formula of finding X component. We know that it will contain what? We know that it will contain cos. It will contain cos. In this case, this FAX, if I have to replace it, I'll put FA cos 25 degrees. Now, we choose the direction. To the right is positive. It means that if the forces point to the right, it will take a positive sign, and then those that are pointing to the left will take negative sign. Then we put the F net equals to MA. What makes up F net? All the horizontal forces. FAX, FT, FF. FAX will be positive, T negative, FF negative, equals to MA. Next step, I don't have the value of FAX, but I can substitute this by putting the formula FA cos 25 because I have value of FA, which is 24. This one is given. So replacing FAX by FAX cos 25 minus T minus FF is then 2. My mass is 5 times A. Then we use the calculator here, or substitute FAX cos 25. It will be 24 cos 25 minus T minus 2 equals 5A. Then we make T subject of the formula. At the end, we have T equals to 19,75 minus 5A. Even here, I have 2 variables. So I'll make it equation 2. See, now I have equation 1 and equation 2. And all of them are or equal to T. T equals to equation T equals to 8A plus 3, T equals to 19,75 minus 5A. So what I do, I must equate the two. Equation 1 equals to equation 2 because all of them equals to T. Then you copy the equations, then you solve for A. You can see that the equation now contains one variable, which is A. Then you solve for A. At the end, our A equals to 1,29 meter per second square. Remember, we were not told or we were not asked to calculate the acceleration. But as we are working, we are forced to calculate this acceleration because it will be very useful for us if we want to get the value of t. Now I know my acceleration. What do? You can substitute this, let me name it equation 3. You can substitute equation 3 in 1 or 2, but I've chosen to substitute it in equation 1. Where there is a, I'll put 1,29, and then at the end, my t equals to 13,31 Newton.